For years, black holes have been the most mystical and mind-boggling objects in the universe, characterized by their bottomless appetite, boundless gravity, and the inexplicable finality of their event horizons, beyond which nothing, not even light, is believed to escape. These mysterious bodies in the universe are the supreme manifestation of gravitational collapse, wherein mass is so densely packed that space itself and time are grossly distorted. They are cosmic prisons, where the laws of physics as we understand them seem to unravel. But in a groundbreaking twist that has captivated astronomers and physicists worldwide, NASA's James Webb Space Telescope has captured an observation so extraordinary, so unprecedented, that it may challenge our most fundamental assumptions about black hole physics. On the far side of a galaxy billions of light years away, near a supermassive black hole that grumbles like a gravitational king within the galactic core, Webb captured what looks like a flow of material, energy, or light, apparently spewing from the region near the black hole itself. It is no typical jet or radiation flash. This effect, observed and recorded with the Webb telescope's advanced equipment, contradicts all we believed we knew. Essentially, it challenges one of the basic principles of general relativity: nothing can ever leave a black hole after crossing the event horizon. Black holes are usually characterized by extremely turbulent environments. Swirling gas and dust accretion disks spin inward, warming to unimaginable temperatures and radiating intense energy as they pirouette ever closer to the edge of no return. Occasionally, matter colliding with the magnetic field of the black hole can produce twin jets, relativistic flows of particles expelled along the axis of rotation of the black hole, spewing outward at nearly the speed of light. But what Webb observed was very different. It wasn't the typical bipolar jet, which is known to arise from areas just outside the event horizon. Rather, what it observed was a very collimated beam, narrow, ordered, and peculiarly displaced, that seemed to come from further into the gravitational well, even possibly within the event horizon itself. This one observation has created waves within the astrophysical community. The beam had a high-energy signal-rich spectrum that included synchrotron radiation, typically found in magnetically accelerated particles. But the intensity, coherence, and continuous emission suggested an origin much deeper than present models can explain. It's not so much that something is coming out of a black hole, it's the way that it's coming out and with what that's upsetting fundamental physics. Webb's unparalleled infrared sensitivity was essential to its ability to image this cosmic oddity. Unlike most telescopes, which have difficulty looking through the dense clouds of gas and dust that shroud the centers of galaxies, Webb is an infrared telescope and can burn through these veils to provide an unprecedented glimpse into black hole environments. The data was dizzyingly clear. Instead of seeing a haphazard burst or flare, Webb saw a regular, rhythmic ejection, nearly a cosmic heartbeat pumping out of the abyss. What's more, this beam wasn't an optical artifact. Its spectral analysis revealed modulation, as if the beam were rhythmically being pumped up or gated by an internal process. Scientists theorized that this might be related to the spin of the black hole, or to complicated interactions between its magnetic field and an unseen quantum process near or inside the event horizon. Such periodicity would indicate a degree of internal structure never before linked to black holes. Instead of chaotic or purely entropic forces, we might be observing a well-structured, self-regulating phenomenon. This find bluntly contradicts one of Einstein's theory of general relativity's core pillars, the event horizon as a one-way boundary. Einstein's equations state that any energy or matter passing the event horizon is forever lost to the universe. But this observation indicates otherwise. It suggests that our knowledge can be imperfect, or that perhaps some process, possibly quantum in nature, can enable energy or even information to leak past this apparently absolute barrier. One theoretical line of thought is quantum phenomena at the event horizon. There are possibilities like Hawking radiation. Historically, Hawking radiation is supposed to be extremely weak and random, due to spontaneous creation of particle-antiparticle pairs at the edge of the event horizon. Typically, one particle drops in and the other one gets away, causing a gradual loss of mass for the black hole. But what if, in the proper circumstances, extreme spin, strong magnetic fields, or certain densities of exotic matter, these quantum operations get amplified and coordinated? Might the black hole itself become a form of quantum engine, emitting energy in coordinated beams outward? A second option, more speculative but no less compelling, is that the beam signals exotic types of matter, like axions or other weakly interacting particles postulated by beyond standard model theories. These particles, if they exist, may be able to escape from areas of intense gravity, even from mere yards inside the event horizon. If so, Webb could have just made the first observational record of dark matter-like particles being thrown out by a black hole. This would not only revolutionize astrophysics but also open new doors in particle physics, bringing to light the mysterious nature of dark matter, one of the universe's biggest enigmas. The formation and alignment of the beam offer still more mysteries. In all known black hole systems, the jets are neatly aligned along the rotation axis of the black hole, driven by magnetic field lines threading the accretion disk. But this new jet defies that rule. It breaks out at a significant offset, which may indicate some inherent asymmetry or even higher dimensional geometry in action. Is it possible that the very structure of space around the event horizon is twisted in such a manner as to form alternate routes of escape? Do there exist places inside black holes where space and time rearrange themselves into something entirely new, something that facilitates information transfer back into our universe? This has led some theorists to revisit considerations of wormholes. If a black hole is somehow linked to another part of spacetime, maybe even another universe, via a wormhole, then it's possible that what Webb saw is the visible tip of a cosmic tunnel. While wormholes are extremely speculative and controversial, the organized, long-lived character of this jet lends the concept new observational gravity. If subsequent data confirms this interpretation, it would represent the first solid proof of such structures, transferring them from theoretical speculation to empirical science. More proximally, the periodic behavior of the beam implies feedback processes occurring deep within the black hole. These might be associated with spin dynamics, quantum structure fluctuations in the event horizon, or some other unseen process. If black holes can breathe, rhythmically expelling energy in the process, it might suggest a self-controlling quality, one that assists in restoring balance to mass accrual and the expulsion of energy. This is precisely opposite to the classic vision of black holes as mere destructive endpoints for matter and energy. Additionally, this finding opens up the notorious black hole information paradox again. For many years, physicists have argued over whether information lost down a black hole is gone forever, a possibility that would contravene the basic rules of quantum mechanics. If Webb has recorded signs of evidence that information, in some intense and altered form, can be released, then we could be on the cusp of solving one of the greatest enigmas in contemporary physics. And this all redescribes our understanding of black holes on its head. No longer just terminus points of star evolution or static anchors in the core of galaxies, black holes might be active participants in cosmic evolution. They may not only suck and squash, but also spit and mold, pacing star formation, powering galaxy motion, and potentially even helping create the conditions for life. If they are capable of spewing out structured energy or exotic particles, then they are as much creators as they are destroyers. The timing of this discovery is critical. Humanity is only just beginning to unlock the full capabilities of the James Webb Space Telescope. Already, it has revealed hidden galaxies, ancient stars, and now, perhaps, the first glimpse of a phenomenon that could reshape theoretical physics. The image of that jet, fine, ghost-like, and impossibly distant, may one day be remembered as a turning point in our understanding of the universe. Webb's instrumentation did not just record the beam's shape and path, but enabled astronomers to gauge its composition and speed with incredible accuracy. The beam traveled at nearly light speed but exhibited slight variations in energy, suggesting that it may not be made up entirely of photons. There may be mass-carrying particles involved, particles outside the reach of present physics. If so, then black holes could be nature's most intense particle accelerators, and potentially uncover forces and elements beyond the reach of Earth-based colliders such as CERN. The beam's steady rhythm also promises a hidden intelligence, perhaps not conscious, exactly, but in the manner complex systems organize themselves. Perhaps this is the first hint of a feedback cycle, where a black hole's spin, magnetic field, and quantum boundary interact with each other, to either modulate its behavior in patterned ways. This brings up a revolutionary new idea that black holes are not mindless voids, but highly tuned machines of cosmic order. Ultimately, what the James Webb Space Telescope has photographed could do more than update our textbooks. It could compel us to rewrite them all anew. Black holes, long viewed as quiet eaters of matter and light, are coming to emerge in a more complicated persona. They could be writers, cosmic archivists who store, sort, and even share the universe's deepest secrets. And now, for the first time, we're beginning to hear them.